Chapter 12.2 Determining if observed frequencies follow a known probability distribution. The next chi-square technique we will discuss is known as a goodness of fit test. The test helps us to decide if the observed frequencies follow a known probability distribution. In the following section, we will test for a general discrete distribution as well as binomial, Poisson, and normal distribution. Testing for a discrete probability distribution. We will start off our discussion of the goodness of fit test by using the chi-square distribution to test if a set of observed frequencies follows a predetermined discrete frequencies distribution. For example, a local Bank of America branch has a drive-through window for teller transaction. The bank managers believe that the weekly demand for services through these windows follow the probability distribution shown in table 12.7. For instance, it is thought that 20% of the weekly volume occurs on Monday. This table also shows the number of daily customers using these windows during a randomly selected week, which represent the observed frequency or FO. We would like to perform a chi-square test to determine if the observed frequencies shown in table 12.7 provide enough evidence to conclude using alpha equal 0.1 that the overall demand pattern follows the stated probabilities. This information is useful in assisting management with planning and staffing decisions. We will do so with the following step. Step 1. Identify the null and alternative hypothesis. The null hypothesis for this test is that weekly demand does follow the stated probability distribution. The hypothesis statement is therefore as follows. Null hypothesis, weekly demands follow the stated probability distribution. Alternative hypothesis, weekly demand does not follow the stated probability distribution. Step 2. Calculate the expected frequencies. For the Bank of America example, the expected frequencies represent the daily demand that will occur if the stated probabilities describe the demand pattern. We calculate the expected frequency Fe by multiplying the total weekly demand 240 by the probability for each day of the week. These calculations are shown in table 12.8. All of the chi-square tests in this section also require that each expected frequency be 5 or more. As you can see, this requirement is satisfied in table 12.8. Step 3. Calculate the chi-square test statistic or X-square. We will use equation 12.1 again with the help of table 12.9 to calculate the chi-square test statistic. A true null hypothesis would result in the observed and expected frequencies being very close to one another. This in turn would cause the test statistic X squared to be close to 0. A large statistic would increase the likelihood of rejecting the null hypothesis. Step 4. Determine the chi-square critical value, X squared alpha. The chi-square goodness of fit test has the following degrees of freedom. Degree of freedom is equal to k minus m minus 1, where m is the number of parameters estimated from the sample in the hypothesis statement. K is the number of categories. For our Bank of America example, we are not estimating any population parameter such as the mean of standard deviation with the sample, therefore m is equal to 0. This example does have 6 categories, one for each day of the work week. So k is equal to 6. As a result, our chi-square critical value has k minus m minus 1 is equal to 6 minus 0 minus 1 equal to 5 degrees of freedom. If we go to the alpha equal to 0.1 column in table 12.5, we will find that x squared alpha is equal to 9.236. Step 5. Compare the test statistic or x squared with the critical value x squared alpha. Because x squared equal to 12.49 and this is more than x squared alpha equal to 9.236, we reject the null hypothesis according to the table 12.6. We can see this graphically in figure 12.6, which shows the test statistic x squared in the shaded rejection region. Step 6. Determine the p-value. We can use the Excel chi-sq.dis.rt function to determine the p-value for this chi-square test statistic equal to chi-sq.dis.rt parenthesis 112.49, 52 is equal to 0.0287. Because the p-value is equal to 0.0287 and less than alpha equal to 0.05, we can reject the null hypothesis. Step 7. State your conclusion. By rejecting the null hypothesis, we conclude that the true probability distribution for weekly demand does not follow the stated distribution shown in table 12.7. For instance, it appears that the observed demand for Thursday was much lower than the distribution predicted. Thank you.